Hi CS400, this video is to get you started with JUnit, to get you set up with it and give you some of the basics. So I'll start with creating a new Java project. So I just named it JUnit Demo and we added it here. And so you have to add JUnit to your build path. So to do that, we'll right click on our project folder. We'll go to build path. And so I'll show you guys two different ways to do it. The first and the easier way is to click add libraries here. And we'll select JUnit. And we'll make sure we select JUnit 4 because that is the version of JUnit that we'll be using for P2. And you can see that Eclipse already has it somewhere in there, so that's great. So we click finish and JUnit, you can see here, is in our project now. So if that didn't work, if Eclipse doesn't have JUnit kind of pre-installed for you, we will have to install it ourselves. So you can go to junit.org/JUnit4 and you should come up to a page that looks like this. Click download and install. This will take you to their GitHub. And then we will be downloading this plain old jar file. So click here, and then we'll click here to save it to our downloads. And so I would recommend, here it is in my downloads, I would recommend that you create a separate folder to store this jar file. I just put it in my home directory, and so I created this folder, JUnit. You can drag and drop into that folder. I already have it, so I won't recopy it. But that way you know where the jar file is, and you'll be able to access it. So then once you have that downloaded, right-click on your project folder, go to Build Path, Configure Build Path, and then here in this Libraries tab at the top, you will click Add External Jars here on the right, and then you will navigate to the folder that you just saved your jar in, click on it, open, and then apply and close. So either of those ways work. The first one is obviously easier, but go ahead and use the second one if you need to. Okay, so now we have JUnit in our build path. So I'll just create a class and then some tests for you guys just to kind of show you how JUnit works. So let's create a new Java class and let it be an object that represents a rectangle, just for the purposes of showing this. So we have our new class rectangle. So let's say that a rectangle has a length and a width. All right, and then we'll put a constructor in there. All right, and so now we have that constructed, and let's just add a method that gets the area of the rectangle. All right, so we return the length times the width. All right, so now let's add in a test class. So we'll go in here, new, and you can do, new file or whatever you want to. I like to add new JUnit test case because it gives you several options. It will kind of create these method stubs for you. So let's call it rectangle test. And so you see that I've selected these method stubs that I want Eclipse to create for me. You can deselect them and do it yourself if you prefer. It really doesn't matter. And make sure it's new JUnit 4 test up here, that's selected. All right. So now it has created a new JUnit test for us, a test class, and we can see that there are these JUnit annotations here. So these represent different things. So basically the before class, any method that has this annotation on it will run code in it just one time before the start of all of your tests. So code here will run once before the start of all tests. And then after, similarly, the code here will run after all of your tests have finished. So code here will run once after all tests have finished. All right, and then methods with this before annotation will run before each test. So code here will run before each test. And then teardown is with this after annotation. Any method with this after annotation will run after each test. All right, so now we have this annotation test, which means that that is one of your tests that you're running. So let's do a test first to validate that the get area method over here is working. So let's call it test 1 valid area, because we'll be feeding it a valid area. So I guess before I go into this, one thing to note, I want to clarify more maybe what these mean. So a good example of what you would how you would use the before class, any method with the before class annotation, is maybe we want this to be a grading script, and we're going to give somebody a certain number of points. So we'll make a field here with points. And then here in the setup, we'll set it to 0. And then in teardown, system.out, we will tell the user how many points that they got. So here we can see that after all of our tests have ran, it will it'll print out how many points they've accumulated. So that's kind of one way you could use before class and after class. And a way that you could use setup and teardown is, let's say you want your rectangle to be a field at the top. So let's private rectangle. And before each test, you want to initialize this to a new rectangle with length 0 and width 0. So you do something like this. And then teardown, you could set it to null, just to kind of set it up for the next test. This is kind of not a great example, because you probably won't want your values for length and width to be 0 for each test. But I just wanted to show you kind of how something like this could be used. All right, so to test the valid area, let's do something like rectangle equals new rectangle. And let's set it to 2 and 4. So length and width of 2 and 4. And we want to make sure that the area that we get back when we call get area is 8. So let's do that. So we'll use this assert equals method. So that's a JUnit method, assert equals. And so we'll give it the rectangle dot get area. So that's our return value from calling get area on our rectangle called rectangle. And we want it to be 8, because 2 times 4 is 8. So I wanted to show you this because this assert equals is actually deprecated. So upon Googling that, you can see that this assert equals with a double expected and double actual is actually deprecated. So it wants us to use double expected, double actual, and double delta. So this delta value is going to be kind of the margin of error between the, if there's different rounding in the two doubles that we're passing in, how accurate do we want this value to be, basically. So we'll set it to be accurate to the nearest thousandth, and that should be fine. So I just wanted to show you that because a great resource is actually, JUnit.org has their Java docs for that. All right, so next, let's, and I forgot, so since we're doing points, we'll give them 2 points for each test they pass. That's fine. All right, so now maybe we want to catch an exception. So let's just say that when we construct our rectangle, if we're given a negative length or width, we'll throw an illegal argument exception. So I'll put the code in for that here. All right, and now we will test to make sure that that code does indeed run, that we do actually throw an illegal argument exception when we try to construct a rectangle with either a negative length or width. So let's write that test here. So we'll add that test annotation so that JUnit knows that this is a test. So public void test2. How about construct rectangle with negative width? That's kind of a wordy method name, but just the point is that you want your test names to be descriptive. So let's try to construct a new rectangle with length of -1 and width of 5, so that shouldn't work. That should actually catch an illegal argument exception. And so when it catches the illegal argument exception, that's actually where the code is good, so it passes. So we'll give them 2 points for that there. And if the code doesn't actually catch that exception, we want to fail. And then you can add a message in here, like should have caught an illegal argument exception. And then if it throws any other exception besides an illegal argument exception, we can write code for that too. So if it catches another exception, we can fail it for like an unexpected exception was caught. And then, yeah. So that's kind of a way that you can test for exceptions. And next, I want to show you how you can check for a Boolean value. So let's add a method into our rectangle class that returns Boolean, and it checks if it's empty. So by empty, I'm just going to define that as if it has a length of 0 and a width of 0. So if length equals 0, width equals 0, then we'll say it's empty. If that is not true, we'll say it's false. So now we want to test this. So let's add another test. Test 3. is empty. So let's assert true. So this is another kind of assertion that you can make in JUnit. I'll post a link to different kinds of assertions that you can make in the comment section. But assert true is just a different kind of assertion you can make. And you can insert that rectangle is empty. And then add a few points. So here you can also add a message like a newly constructed rectangle with length equals 0 and width equals 0 should be empty. So this just gives back, I'll show you when we run it, it kind of gives you that message if you fail that. And then, so one more test, I want to tell you a little bit about JUnit rules. So let's say we have a test that maybe has an infinite loop in it, so it runs forever. So let's do test 04, runs forever. And we have some kind of infinite loop here. So that, once we run it, is going to just hang there, and it's just going to run in an infinite loop. So that's no good. So how we can fix something like that, where a test might get caught or take too long to run, we can add a rule. So we use this annotation rule in JUnit, and the way we can set a timeout is public timeout, global timeout equals new timeout. Set it to 2000 milliseconds or 2 seconds. All right, and that will have imported something for you. And we have to import this. So that should be good. Oh, and we have to import a rule. So you might have to import a few things there. But this line of code, our JUnit rule, should allow us to end that test after 2 seconds. So that test, you can see it timed out. We got this test timeout exception. So that's good because we don't want our computer to wait for that test to run forever. So I think that's most of what. Oh, and I was going to show you how these messages work. So this message here that I made. So let's just say that this is assert false. So now this should actually fail that test now, which it did. And we can see here this error comes up with the message that I passed in. So it's just a way to give a little more of a description as to why that test might have failed, which it shouldn't have. So just make messages that make sense and that describe what you're trying to do. So I think that's pretty much all I want to show you for the basics of JUnit. Now you have kind of a starting point to go off from. And yeah, thanks for listening.